in our EthVan talks. We do this every week, Thursday. We also have Nouns Running Club on Saturdays. So if you're into running, we run along the seawall. Noon, we meet at the Cactus Club in Cole Harbour. So we'll start from there and do a 5K there. And then we also have, what other events do we have up, Tangle? Won't be doing ZK for a little bit. But we do, on Wednesdays, we usually have a ZK night. I'm just gone for a little bit. And then anything else? Are we doing Solana?
I'm not sure yet. There might be
maybe a Solana event?
We're looking at doing a Solana event here, potentially like either April 26th or 28th, something like that, somewhere in there. So the end of April. They'll be coming back here. So we'll time that around. We were kind of looking at a Wednesday, so we'll time that around ZK stuff. Yeah, that'll probably be the next potential thing. And yeah, other than that, yeah, I think there might be NFT and coffee. I'm not sure. You'll have to check that on the meetup when it's next. I'm kind of losing track with the every other week thing going on here. So, but yeah, that should be it.
Cool. All right. Thanks for coming, guys. I have been deep in the cryptography space. Not like I don't think I know a whole lot, but I've been digging into it. And I think something that's really interesting popping up more so recently, as there's more like, you'll see raises and stuff in this area, but Fully Homomorphic Encryption, also known as FHE. It's kind of a big name that's scary, but the concept is actually pretty simple. And it's a really cool technology that kind of unlocks a lot of solutions, which it's cool. We'll get into it. So first we'll start off with like what is FHE and what does it solve? And so fully homomorphic encryption actually kind of started as homomorphic encryption. And so what homomorphic encryption means is you just have some data. You can then encrypt it with your key, and then you can operate on that data. So you could add like two pieces of data together, and you can do this without knowing any of the data underneath. You can just know that the output will be an addition of these two values, or a multiplication. And so homomorphic encryption, I believe, only supports addition and multiplication, or some subset of operations, but not all of them. And so then comes fully homomorphic encryption, where you can essentially do any operation on encrypted data, which is really cool because like I could send you some data and you can do stuff with it, but I know that you'll never learn what my data is. And the output is also encrypted. So like back here, let's say, oh, we add these two together, we're gonna get a sum that's encrypted that you can only decrypt with this key. So it's kind of an interesting problem. So yeah, essentially it's just allows you to perform any operation on encrypted values. And so another popular thing in the space is ZK. ZK is a little bit different, but some of you may be a little bit more familiar with it. What ZK allows you to do is you take some data and you can do some operation on this data, and then afterwards you can hide part of it, and you can say, this result was adding two numbers, this is the output, but I'm not going to show you these inputs, but I can verify to you that I added these two things. So it's more of a proof of authenticity on the operation itself, but it doesn't help you with hiding this information. The person that generates this proof has to know the information. With FHE, what we can do is we can just encrypt this, send this, and the person operating doesn't have to know what it is, but they can still operate on it, which is really interesting. And then when we get this back, we can decrypt it. But this whole process is kind of, the data underlying is unknown. The other thing about FHE is that it's really better for companies that don't want to share their programs, because with ZK, you get a stamp of approval that this thing happened. The two things were added. And if you wanted somebody to run that, they would have to know what the program is. With FHE, you don't get any sort of authenticity of what happened with your data. You just know that the person that operated with it didn't get to see it. So it's a little bit of a different problem solution space. But this makes FHE really great for companies that don't want to share their programs. Because if you wanted to do some decentralized solution or privacy preserving solution, with FHE, I can just encrypt my data, send it to OpenAI or an insurance broker, and they don't have to worry about me knowing their thing. If we use ZK for this kind of problem, they would have to send me, oh, okay, this is OpenAI's model. And what it does is it adds these two things. And now I've just learned all of OpenAI's secrets. I still don't have to show them my data. After I add it together, I can be like, hey, this is my result. But it's not exactly as great of a solution for companies that don't want to share what happens underneath. And so, yes, ZK is only suitable for open source programs that can be shared with users. And the other thing about ZK is that you have to know all the data. So if I'm doing this operation and I'm providing this proof afterwards, I have to know what these inputs are. Whereas with FHE, if I have somebody else's data and my data, we can add these two together, and the person operating on these doesn't have to know like the other person's data. So kind of getting a little more complex there. But as an example, machine learning, I'm deathly allergic to peanuts. How can I make sure that no one malicious finds this information and uses it against me? So in a scenario where FHE is super fast and we could run OpenAI on it, what I'll do is I'll encrypt it, encrypt my input, send it to OpenAI. They'll run ChatGPT on this using their FHE ChatGPT, and then they'll provide me some response. And that response would also be encrypted, which I then can decrypt with my key. So in this scenario, OpenAI actually learns nothing about what I sent them. They just provided me their program as a service, and I get to hide my information still.
Well, what good is it if it says I can't?
Exactly. I can't answer that for you. Well, shoot, I should have ran this model on my own computer and whatever. But yeah, so that's one example. Or you can just expand this onto any program. And so let's say an insurance broker wants to run this. And then don't have to provide them with my data, but they can provide me a response. So this is just kind of like general FHE, just any sort of computation. There's also a recent kind of concept, the FHE VM. And so like Ethereum's virtual machine you can write smart contracts, but all this data is visible. So if we have an FHE VM, the idea is to create encrypted values. So you can have, like, instead of a Boolean, you have an encrypted Boolean. Or a normal uint, you have an encrypted uint. And so what this does is you can do all these operations on chain, but the data underneath is hidden and nobody gets to know what those values are. So like, I want to add two numbers. I'm going to add a EUint 8 and A and B, and then I'm going to get another EUint 8. And so that's just using the FHE add function, and you can do all these sorts of functions on it. And then if you want to kind of reveal the result, you can have some sort of logic that allows the contract to reveal it. So then we have this like FHE decrypt. This will make more sense in another slide, but essentially what this is it's private, collaborative, on-chain data. You can't do this with ZK because you can't collaborate on data. FHE allows everybody to collaborate on data while keeping it private. And so if we were to do like, I wonder if I can zoom in here. I don't think I can. But this is an encrypted ERC20. So like, let's say we have some token, Pepe, and we want to transfer this amount, but in this scenario, because we can use FHE, we can hide all transfer values. We can hide all values we want to. And so then a transfer would look like this. We would have a from address, a to address, and an encrypted amount. So I can send you some encrypted amount. And then what we would do is we would just check that, hey, I'm sending you this value. My balance, which is also encrypted, is less than or equal to the amount. And we can do this check, and everybody gets to see that, yes, this was correct, but we don't get to see what either of those values were. Then after, we're going to add the amount to your balance and subtract my balance, or subtract the amount from my balance. And so we have this private transfer. And some value is transferred. Nobody else on the outside gets to know. The one sending it gets to know how much was sent. Oh, and then when, let's say I receive this private transfer, I don't really know how much it was unless the other person told me. So then I want to check it. And so what happens here is we can check like this balance of function, and this requires me to provide a signature. What happens now is that only my account is able to view it. And what happens is essentially the chain encrypts this data that was already encrypted using the chain's key, encrypts it with my public key, and then decrypts it with the chain's key and sends it to me. This just means that only I get to see my balance, nobody else can see my balance. And so if we look at this kind of example here is with the FHEVM, there are encrypted inputs and outputs. So the user sends a value M encrypted with the blockchain's public key, and that's encrypted in input to the blockchain. The smart contract homomorphically computes, so it does these add, less than, whatever operations you want, on the encrypted value, and it's encrypted, and then when the user wants to see it, it's re-encrypted with their public key. So kind of taking a step back from what it actually says here is that the blockchain, like, these are all validators. They all have a key, and that key is combined into this blockchain public key. And so when I want to send some encrypted data, I can just encrypt my data using that blockchain public key, send it there, and then it has to go through all of those validators to decrypt it when I want to see it. And now if we just decrypted it like normal, then everybody would get to see it. But if we first encrypt it with my key and then decrypt it, and then only I can decrypt it after that. Gets a little bit more complex there, but yeah. Any questions about that so far? Okay, cool. And then here, yeah. So each validator holds a key, and then we need like, I don't know, 5 of 6 keys in order to actually decrypt the result. So what can we actually do with this? Here's some examples from the main company that's created this. We can swap tokens and real world assets without anybody seeing the amounts. It's kind of like the encrypted ERC20 that we saw. We can do blind auctions, so you can auction off some tokens and nobody actually gets to know the price until after, or you can even hide the result after. You can do on-chain games because it's collaborative, so I can have some health value that is secret, but I know I'm about to die, but nobody else does, so maybe they waste their resources on me or something. And then we have another, like confidential voting is super easy with this. It's possible through ZK, but it makes it way easier with FHE or encrypted DIDs, private transfers, bunch of different stuff that you can do that you couldn't really do before. Or some solutions with ZK are too difficult to do. So who's using the FHE? Let's see. It's basically just Zama. Zama has been kind of spearheading FHE in general for a long time, and they've created the FHE VM recently, as well as Concrete. Concrete is a library that allows you to just take Python code. I don't know if you can take any Python code or only some types of Python code, but then turn it into an FHE equivalent. And they just raised 73 million, so they've been like in a lot of feeds and stuff recently. But yeah, their whole plan is to go with this FHE VM and then turn the entire internet into FHE programs. So more than just encrypting with HTTPS, you could encrypt all of your data, and it's all done through FHE. And then there's FHE VM chains. So Zama's actually not running their own chain, but they're providing this infrastructure so that other people can choose to go ahead with this and create their chain. So there's 2 main ones. There's Inco and Phoenix, and they're both using Zama's FHE VM. And then so, like, this would be awesome if it was super easy to, like, it is super easy to use. From a developer standpoint, it's awesome and way easier to use than something like ZK. But of course, there's limitations, and those limitations are fairly big right now. So like when you're doing normal operations, it's, I don't know, a nanosecond to add two numbers, right? But if we add two encrypted numbers, it's like 60 milliseconds. So you're not going to run OpenAI on this. You're not going to run a lot of massive programs, at least for now. And keep in mind that all of these statistics are ran on an Epic, one of the largest AWS machines you can use, with 768 gigabytes of RAM and 192 virtual CPUs, 3.7 gigahertz. And the cost of running this machine a day is around $180 to $200 US. So we have a long ways to go. we're not there yet. But let's assume that this moves at a groundbreaking speed, which ZK has moved at a crazy amount of speed. People will say that FHE is kind of ZK from a couple of years ago. It's like, let's say in a couple of years ago, or in a couple of years, we're at like 1 millisecond to add these numbers. What should we build? So I think some interesting ideas would be a private ad network. So right now, Google holds all your data or whatever conglomerate, and they go to, or advertisers come to them and they say, hey, I want to advertise to people that are in Vancouver, they're of this age range and whatever. They get to see all of your data, or Google does at least. But what if we just had a network where you sent your encrypted data, and then they can check that, oh, you fit these descriptions. So like, let's say I have my name is, my age is, my address is, whatever. I'm going to encrypt this, and then I'm going to send this to the ad, Google, whatever, encrypted. And then an advertiser can post this algorithm and say, hey, I want to deliver this ad to a user if they live in British Columbia, if they work in crypto and they're under 25. And then this algorithm would determine, oh, okay, yep, this person suits it, and we can send this ad to them. But all that they learn is some kind of foggy haze around my actual data. Now, as a user, I have to be careful that like they're not going to check, oh, this person advertised to people that are these exact specific things, because then that could give more information about me. However, like, this is pretty cool because you can just solve a lot of data issues, especially data leaks, if it's all homomorphically encrypted. So with this, like, yeah, advertiser doesn't get to see the user's information. The advertiser doesn't have to share their algorithm with the user either. So you could do this with ZK, where the advertiser says, hey, I want to deliver to ads to these people. And they send me this, and I'm like, hey, I fit that user group. But I could just make up my data and be like, yeah, I fit that user group. Send me the ad and pay me for it. And then you get a bunch of people just farming these ads and getting some rewards, right? So there's some difficulties there, but that's with ZK. With FHE, it would be much easier. Another interesting thing, and I've worked on a solution like this before. I realized some issues with it, but it is possible if done right. You could do a hidden order book. So you have a normal order book, you see everybody's orders. The issue with this is that when you have a $20 million order and you dump it on the order book and everybody sees it, they're like, it's super bearish or it's super bullish, and the market changes and that person that dropped that order gets screwed. So what if instead you could just encrypt this and send this to the order book, and you can check that, like, in this smart contract, yes, this order was filled, but nobody actually gets to see the price that it was filled at. Nobody gets to see the size that it was filled at. Nobody gets to see anything. The person that dumped this order says, yeah, I got my order sold at this price that I asked for it to sell at, and it doesn't affect market sentiment. Yeah, do we have a mic? Yeah, no worries.
Dark pool. So is that, it's similar to OTC then?
Kind of, but essentially, like an OTC, you have to go through a broker, right? So this broker is going to know that, hey, this person wants to buy 20 million. I'm going to front run them, or I'm going to mess with them, or whatever. This, literally nobody gets to know what your order is, which is really interesting. So then you can trade size without impacting market sentiment. You also can't get front run or sandwich attacked or anything because nobody knows what your order is. So you can't really front run somebody. And it's also largely used in TradFi. I believe how it's done in TradFi is you just trust some broker that doesn't post the order book and they just operate it. But obviously you don't want to do that. A really interesting company that's done, they've just released recently something similar to this. Now it doesn't use FHE, it uses MPC. But what they do is they have a bunch of separate pools. It's called Renegade.fi. And what they have is a bunch of like different pools. So I can be a pool manager and I can see what orders are in that pool, but I can also trade and fill orders with other pools that I don't get to see. This is kind of diverging from FHE. This is more MPC. I don't believe they actually use FHE at all, but it's in the same realm. And you could do this with the FHE VM. The only difficulty is that it can't be an AMM, has to be an order book, and doing an on-chain order book is not so easy, but could be pretty cool. Another kind of idea is gaming. So I feel like this is kind of an unexplored area, so it's maybe not clear what the possibilities are. But like, let's say I had a game where I have 1 health left and whatever, and I want people to, maybe I have another life, but I want people to like really waste their ammo on me, even though I'm about to die. They don't get to know that, and nobody gets to know that. Or you could have all sorts of mechanics. I don't really, this is all I could think of, but I'm sure there's a lot of different like new dynamics that you don't have in a normal game. I've also built, like using the FHE VM, I've built Battleship, which is kind of interesting because it's an on-chain version of Battleship. You are collaborating on the same state, but it's done on-chain and all private. No. That's, I'm curious if you guys have any other ideas of like what could be done, or if you have any questions about like what FHE is, because it's probably not super clear yet. Hopefully I made it make a bit more sense, but yeah, just think, yeah, go ahead.
Yeah, so I have a bunch of questions, but I'll probably ask you a bunch after, so I don't take up all the time for
Oh
questions.
no, well we're on stream, so
oh, okay, cool.
go for it.
Yeah, so to access this dark pool, you cannot do this dark pool thing on like Ethereum or anything,
So
right? Or
with Renegade, they do. It's like a network outside. So it is like, it's not all on chain, but it is a distributed network. Or like with this FHE VM, I should clarify also the FHE VM isn't like on mainnet. It's another network that's running this FHE VM, but it uses the EVM. So you could run a dark pool in the FHE VM on some chain. I can bake it in L2 if I wanted to, but it's not on mainnet. And using FHE VM, it would be fully on-chain. This Renegade solution is not fully on-chain, but... Yeah.
so Renegade is where I go to find these dark pools, to find out how to do this OTC, well, not OTC, but to do these deals. I go to renegade.fi.
Renegade is somebody who's built dark pools, not using FHE, but they have dark pools.
So if I want to do like a deal of, let's say, whatever, 1 ETH, and I don't want anyone to know about it, like I go to renegade.fi to do that.
Yeah. They're still in testnet. I think they okay. Well, I looked at their code and I thought it was released like 2 days ago, but I might be wrong, so it might be.
Oh, so this is not live right now, you're saying? Or
No,
Renegade
not on
specifically?
mainnet yet.
Oh,
Renegade.
so no one can use this right now, is what you're saying?
You can use it on testnet, but no, not on mainnet. It's not out yet.
Okay, so no one can do these deals right now, live, with real money. Okay.
Yeah. But hopefully somebody can make it. Or Renegade will be on mainnet soon. So.
A date for that? Or is there a date?
yeah, no worries. I just thought follow him on Twitter and stuff. Yeah.
Is there a place where there are like all the different projects listed, kind of like a CoinGecko of this?
So like FHE in general is still too new for like no projects are out there using it right now, as far as I know. However, Zama has like an awesome awesome Zama. And so they have like a list of a bunch of tutorials. Okay, like let's say libraries and solutions. Oh, those are Zama solutions. Yeah, I don't know if there's too many like actual products out there. But I would take a look at this. Awesome Zama. Like I said, Zama's kind of like the main player in this space, and there's not really too many others. There's a bunch of like smaller things, also privacy and scaling explorations. The PSE is a subgroup of the Ethereum Foundation. They're doing some stuff in FHE. But at size, Zama is kind of the leader. So I'll just take a look at them, see what's out there.
Thank you.
Yeah. Any other questions? Yeah.
I was curious, what's the state-of-the-art trustless version of ZK solution is like? Because I think, as far as I know, it was still very slow, right? The ZK Stark solution that, and most of the ZK stuff out there are still involve some kind of trusted setup, right?
So Starks don't involve a trusted setup.
Right, that's what I'm saying. The trustless version is very slow, right?
So it depends. So also trusted setups are kind of, I don't believe they're super like they're not trusted as much. I mean, so the state of the art trusted setup is perpetual powers of tau, where thousands of people have contributed to this randomness, and at least one person is honest, then it's trusted and you can trust it. So if you like were super weary about it, you could provide your randomness to the perpetual powers of tau yourself. However, yes, proof generation is still quite large. There is new stuff out there all the time. So I believe kind of what a lot of people are using is Plonky 3. There might be something new by now. But there's also like, I'm a big fan of Risk Zero. Risk Zero essentially allows you, they have written circuits for all of the RISC-V architecture gates. So like, there's Intel, AMD, ARM processors, but there's a RISC-V architecture, or sorry, x86 ARM RISC-V, and you can compile Rust to a ZK circuit. So that is what I would use. They're pretty fast now. I can probably find their benchmarks, but yeah, I would take a look at them. I'll see. No. Where are they posted? No. Come on. Okay. So let's say they also have Metal and NVIDIA support. But let's say we run Ketchak proof. Proof duration is like 6 seconds. So I can prove the precompile of some hash in 6 seconds. That's, what else do we have?
Those are on the far left column. Those are the algorithms?
Yes. So
Because Blake 2B has seal coin.
yeah. So then you could do Blake 2B in like, well, proof duration 6 seconds, I think. Yeah, 6, 3, 3. Now I'm not sure. Like, I mean, this is a big table. There's a lot of factors, and then we have proof size here as well. But also, risk zero isn't the fastest out there. So I don't know.
and this is the trusted version, right?
So risk zero actually uses Starks.
Okay.
So
okay.
risk zero does not
this
have a
is the
trustless setup.
trustless. Yeah.
Yeah.
Okay.
They have, so if you want to use risk zero on chain, they do a Stark to Snark conversion because Starks are very difficult to do on chain because they're so big and the verification isn't super succinct. But that would involve a trusted setup if you want to bridge risk zero proof to mainnet or whatever chain. Yeah. Oh, you wanna? Yeah.
What coin is on Blake 3 again? The algorithm? I'm just curious.
I don't know. Yeah, I'm not sure.
Maybe just a quick one here. When we're talking about like things being slow and the size of like compute needed to make this happen,
Yeah.
what does the future of that look like? Does
So-
will things do things get more compressed, or do we
Yeah.
are we always gonna have to scale up on compute, or what is that? What's kind of the future looking like there?
Yeah, I feel like it's a little bit of everything. There's a lot of companies looking, saying, oh, okay, like so SP1 is a competitor to Risk Zero, and their plan, I believe, is to go hardware acceleration and like build specific units to run these proofs. There's also like Risk Zero I showed you. They have you can run it like they have metal optimizations and CUDA optimizations, so you can kind of take existing compute, and then also there's like optimizations in the software itself. So it's kind of, I think a lot of people are taking it from all angles. I would be happier if it wasn't in the direction of specialized compute, because then it gets bought up by Amazon and Amazon runs it all on their servers. If we optimize for your phone and we optimize the software more rather than the hardware, then we can have a more decentralized future where I'm running a proof on my phone. I don't need to send all my data to Amazon's server to do it there. So people are working at kind of all fronts on this, but
Gotcha. Thanks.
yeah. I'm not sure. Like, I don't know what the plan is for FHE or like where optimizations can be found because it's so new. So I think a lot of people are just kind of like poking around and prodding at it and seeing like, oh, okay, maybe we find this breakthrough that just 20x's all performance. But who knows? There was a big conference last weekend in Toronto, actually, FHE.org, the biggest FHE conference. I missed all of the information from it, but there's probably some recent updates there. So, yeah. Any other questions? Yeah. We'll get you a mic.
There is a company called CryptoPoll.org who set up a voting system. So do you think it's with the FHE solutions? Have you heard of that?
It's probably not with FHE. CryptoPools.org?
No, Poll.
Poll.
2 L's.
Yeah.
.org.
Okay. It's probably not FHE based. It seems like more of an MPC solution. And so MPC is where, I'm not sure if this is MPC, but it looks like it. MPC is just like a multi-party computation. So I use my keys and you use your keys, and at some point we both reveal the information, but we kind of work together on it. I'm not sure what this uses. There's like Macy, minimal anti-collusion, I can never remember what the I is, infrastructure. And so this is a ZK solution to private voting. And I'm hoping to dig into it soon, so I can't really tell you too much about it. But yeah, there's like, private voting is really, really hard because you have to have this collaborative, like, okay, did you double count? How did you say that you didn't double count? How do you prove that, like, what you voted for? How do we get this information at the end? Because if you voted, then and we don't know what you voted for, how do we reveal that without you saying, "Oh, this is what I originally voted on"? There's a bunch of difficult parts about private voting, which are difficult. FHE just eliminates all of that because you can just say yes or no. You have this encrypted Boolean, and then at the end, we can all choose to, okay, the voting is over, and we can all choose to decrypt this. Yeah. Also, to be clear that like Sama's FHE VM is not just FHE, it's FHE and MPC and all of these crypto technologies together. But yeah. Right. Cool.
Alrighty.
Cool.
Well,
Yeah, if you want the slides, I realize I made this QR code pretty small. I should have made that bigger. But if you want, you can scan this, and it's just a direct link to this drive with the slides. Yeah. Thank you all for coming.
yeah, big round of applause. Awesome. Thanks very much, Owen. And for anybody tonight here, there is a POAP, so that black poster on the wall. Take your phone, go up there, tap your phone to that nice little area that has the little POAP symbol. Tap it on there, and you'll be able to mint a POAP for free. Watch closely here as down with the iPhones, it's on the top of your phone, and with the Androids, it's in the middle. Make sure that you have NFC on. Yeah, all you have to do is put in your ETH address or your ENS, or if you don't have either of those handy, you can put your email in and mint it there. So be sure you do that before you leave. And yeah, if you don't mind, just help fold up your chairs, and we'll just tuck them behind the door there. Okay, thanks everybody. See you next week.